All right, so we created the predicates to call the print employees by age method in the last video. So let's just run this to see that it does actually work. And you can see we have successfully got both methods working now, both the employees over 30 and also the ones 30 and under. So as you can see, the predicate arguments are just lambda expressions that match the predicate interface. They accept one parameter and return a Boolean value. And I would hope that at this point you're thinking that this is actually quite powerful, because we can pass all sorts of conditions to the method, and we don't have to write a different if condition to filter the employees based on different age criteria. All we need is a new lambda expression that can map to the predicate interface. Now, I mentioned in a previous video in this section that we don't have to use lambda expressions. We can always use an anonymous class, and that's also true in this case. We can pass an anonymous predicate to the method. So let's do it that way to print all employees that are younger than 25. So let's add this code to the main method below the other calls that we've added to the print employees by age method. So we'll do a print employees by age, employees as was before. Then the heading is going to be employees younger than 25. Then we're going to do a new predicate. And I've got the option there by IntelliJ. If I press enter, it'll create the anonymous class for us, like so. And notice how it's already overridden the Boolean test. So all we need to do there is return an expression. And the expression obviously needs to return true for whatever condition we want. So in this case, we're going to return employee.getAge less than 25 to be able to print out all employees who are in fact younger than 25. So we do that, and now if we run this, we can see employees younger than 25, Tim Bachalka 21, he wishes, and also Snow White who was 22. So that's obviously working as well. So yes, we can use an anonymous class here, but when working with interfaces in the java.util.function package, it is more common, and I think personally more convenient to use lambdas. But if you're reading code that someone else has written, then that's what you'll see. But if you really don't want to use lambdas, it is possible to do everything by using anonymous classes like I've shown you there. Now, the consumer and predicate interfaces are general interfaces. They don't care about the type of parameter being passed to the lambda expression. They're using generics to infer the type. Now, there are other consumer and predicate interfaces that expect a specific type of parameter. For example, the double consumer expects a lambda expression that has a double argument. Now, there's also an int consumer and a long consumer. In addition to predicate, there's also double predicate, int predicate, and long predicate. Where possible, you probably should use the more specific type of lambda to improve readability. So just in line with that, let's add an int predicate to the main method that actually tests whether an integer is greater than 15. So we can do that by typing int predicate intp equals I lambda arrow token I greater than 15. So right now the int predicate doesn't do anything. Just like an anonymous class instance that we assign to a variable, we have to actually use it somewhere. So let's print out the value of the predicate for the value 10. Now remember that we have to call the method that the lambda maps to, which is test in this case. The value we're going to pass is 10. So let's just try that. So we'll do a print out system.out to println, and we'll do intp. Then we've got to call the .test and passing the value 10. And we should get a false for that if we run it, because of course 10 isn't greater than 15. You can see we get false printed to the console. Now we can pass any integer value to test, including a mathematical expression that returns an int variable, or a method indeed that returns an int. So let's use the result of, say, a variable and adding a number to it just to confirm that this actually works the way we think it does. So down here we'll put something like int a equals 20. We'll print out intp.test a plus 5. And we should obviously see through in that scenario. if it's working as we think it will. And you can see true is printed out to the console. So this shows us that we can reuse predicates in this way. And now another cool thing about predicates is that we can chain them together. For example, let's just say we wanted to test whether a number is greater than 15 and less than 100. Now we could update our existing predicate to include the second part of the condition, but let's just say we don't want to do that because we want to use our existing predicate perhaps elsewhere. What we'd do in that scenario is create a second predicate and chain it to the first one. So first we'll change the name of imp into something more descriptive, and let's use some refactoring to rename that. So I'm just going to right click here and do a refactor, rename. And we'll call it something more descriptive. Let's just call it greater than 15. Greater than 15, which is what it is. Press enter there. Now let's then create a second int predicate, and that's going to test whether an integer is less than 100. So I'm going to type int predicate, and we'll call this one less than 100, equals I, lambda expression, I less than 100. And now what we'll do is we'll print out the results, but we'll use the dot and to chain the two predicates together to print the result out. So the way to do that, we'd do a print out, s out, and then we're going to do, we'll start with greater than 15, dot, and less than 100, dot, test 50. So let's run that. You can see we've got a true in that last scenario, and the true is that the number 50 is greater than 15 but less than 100. And incidentally, the test method will return true if both predicates return true when evaluated, and false if one of the predicates returns false. Now if we do that again in another scenario, let's just add another line there where we know we want it to fail. So we'll say 15, which is going to cause obviously the greater than 15 to be false, but the less than 100 will still be true. We run that, we should get a false because one of the predicates is now false. You can see down the bottom we've got false showing. Now you'll notice that both our predicates use I as the parameter. Now remember that each lambda expression is like a nested block. So imagine each line of code surrounded by curly braces. So again, the actual scoping that's working in this scenario for lambda expressions is something like this. Int I, return I greater than 15, and ignore the error there because this is only for illustration. So another one, int I, and return I less than 100. So that's essentially what's happening here. So in other words, each variable is within the scope of a single lambda, and that's why it's okay to use the same name here. Now whether that's good for code readability, of course, is a different question. Now the predicate interface also contains OR, negate, and is equals methods. The more specific predicate interfaces contain OR and negate, but they don't contain is equals, and they don't extend predicate. The AND, OR, and negate methods can be chained together. Now this chaining is useful if there's a situation where we need to build a condition on the fly, or when we want to reuse some predicates in different areas of our application. So next we're going to take a look at the supplier interface. Now a supplier doesn't accept any arguments, and it does return a value. So let's look at an example. So let's just assume that we want to print out 10 random numbers. So I'm going to just delete this scoping code that I added. Right, so I'm going to delete that code. All right, so let's just come up with a scenario where we want to print out 10 random numbers. The first draft, we could do something like random equals new random. Then we could do for int I equals 0, I less than 10, I plus plus. And you could print out random.nextInt. And if we run that, we should see 10 integers showing. And there you go, so 10 integers showing on the screen there. And obviously if we wanted a smaller subset of numbers, we could pass a parameter, say, to use the range 0 to 999 and run that again. And we're going to get numbers within that range. So that's working. So So let's change the code to use a supplier instead. Now, because a supplier always returns a value, we have to include the expected return type when we declare it. Now, we're going to use the get method to get an object from the supplier. So the revised code would be, the first line will still be the same, but the line after the random, we're going to put supplier, and the type's going to be integer, random supplier equals, we're writing up a lambda expression, no parameters, arrow token, do random.nextInt, and let's pass the same number again to get a range of them, 1,000 in this case. And then all we need to do at this point is leave our for loop in, but instead of printing random.nextInt, we're going to print random supplier dot get. So if we run that, you should find that we still get 10 integers, just like we did with the previous code. And there's our 10 integers. Now notice the empty argument list here. That doesn't look at all interesting, and just as with other lambda expressions, we can pass suppliers to methods. So we could have a situation where sometimes we want to supply an object of type A, and other times an object of type B, where B is a subclass of A. Or perhaps we may have a case where a supplier is providing an IO stream or is used as a counter. So we can also use suppliers when testing an application. A supplier could instantiate objects and perhaps populate them with random values. So just as with predicates, there's more specific flavors of suppliers. There's a Boolean supplier, a double supplier, int supplier, as well as a long supplier. So I'm going to finish the video here now. In the next video, we're going to continue on and we're going to start looking at a function lambda, which uses the function interface to call lambdas in a different way. So let's work on that in the next video.